Hey guys, want to go over a few of the design features of the power thruster. So right here we have a normal top gauge. It's really just a connector. The really only purpose this serves is to get from your sucker rod to your plunger. All this is going to do for you. And as you can tell right here, here's where your fluid comes out. Well, this piece right here would imitate your plunger. And the fluid's going to come out here, and now on the upstroke, any kind of debris is going to go right here. Now from here to the top of your plunger and on beyond, there's no fluid movement. So once the sand or any kind of debris gets in this area right here, there's no return. It can only go down and scar your plunger. That's all it is. Get that out of the way. Now, this acts like your plunger. Now we have the fluid movement from the top of the plunger up, so there is no dead zone. Every downstroke, you're thrusting fluid through here, which self-cleans itself, so it's taking any kind of debris and thrusting it back up into the solution and running away from it. Now then, on these ports right here, these ports right here are designed, if you want more fluid, you can run more fluid, like in a heavy oil situation. Now we're going to be pumping more fluid than we would on a normal top gauge because we have the ports up here and the ports here. So these still self-clean, but you're moving more fluid when you don't use a ball and seat. Now then, if you use a ball and seat, you're going to close off by that hole down there that communicates with these ports. Put a ball in there, it closes off these ports. Now we're just going to flush all the fluid through these ports, which gives you a higher thrust PSI, so you're really thrusting harder with no ball and seat. But if you need more fluid to go through your top gauge, don't run a ball and seat. And now we have a purpose of running more fluid through it for heavy oil situations. Now then, on the design of the bottom, if you have that hole right there in the bottom of that, just like your seat. So if I put this ball in here, top of the radius of the ball is going to go inside the hole a little bit, so it acts as a cup. So there's also a concave bottom to that, so it helps protect your ball. Just as this will fit in there by chance. So that's no different than your seat. So your ball goes on the seat, helps protect it. Right? So you're going straight up and straight down. So the concave bottom helps protect your ball. So when that ball goes up and down. Now then, those holes are designed on the outside of your ball. So those, the fluid is centering the ball in the cage. That's why you see no ball guides or anything, just like the HBG cage. So the fluid is actually guiding the ball straight up and straight down and protecting it from the wall of the cage, so it doesn't beat out. There's no possible way this cage can beat out when the fluid's running through it, because the fluid itself being guided through each of those ports is making a ball guide, but it's a hydraulic ball guide. So now your ball is just going straight up and straight down. No beat out. These cages, if you put a ball in them, they beat out. You either got to go hard lined, but eventually they beat out. So here, no beat out, so we can run a ball and seat or no ball and seat. Self-cleaning every downstroke. We're actually thrusting any kind of debris back up into solution and running away from it. And then on the upstroke, we're able to gather any kind of debris that's left in the barrel or in the pump and do the same thing over and over and over. So self-cleaning every downstroke. We need more fluid. We have this port here. Just so many benefits of running a power thruster over your normal top cage. Like I said, it's just a connection. This is actually doing your pump some benefit. So give it a try, power thruster. Thank you.